Okay, so we're going to be doing the laws of logs, and I'm only actually going to do the first two laws. There's 3 laws that you need to know. So if you have your highlighter, take out your highlighter, and let's highlight this first law, which is the product law. Okay, if I gave you the log base 2 of 16 plus the log base 2 of 8, up to this point, what we would be doing is we'd be evaluating each log. So if I take the log base 2 of 16, let's just write it off to the side. So log base 2 of 16, doing it the long way, we would have said, okay, let that equal to x. And then we would have said 2 to the power of x is equal to 16. We would get common bases. So 2 to the power of x is equal to 2 to the power of 4. So this answer is 4. Then we would have evaluated the next log, and let's actually just do this one in our heads. Log base 2 of 8 is what? Is 3. Yes, because 2 to the power of 3 gives you 8. The answer, when you add these 2 logs together, is going to be 7. So what happened is people, when they were looking at logs and like starting to explore logs, they said, okay, both of these logs have the same base. Is there some sort of law or a rule that we could use to evaluate these as one log? And what they figured out is if your logs have the same base and they are being added, you could multiply the arguments together. So what that would be is log base 2, so let's actually just, they've got it written here. So log base 2 of 16 times 8. So when 2 logs are being added and they've got the exact same base, it's going to be the product law. We multiply the arguments. So then you would say, okay, that would become log base 2 of 16 times 8 is 128. So what this law has done is it's condensed 2 logs down to 1 log. Eventually I'm going to give you a question where there's 5 logs. And instead of evaluating 5 logs individually, if the bases are the same, we're going to use all of our laws and condense it to 1 log. So now what I could do, I got 1 log, I could say, okay, that's equal to x. Then 2 to the power of x is equal to 128. If I did my common bases, 2 to the power of x is equal to 128 would be 2 to the power of 7. So I get the exact same answer of 7. So that's what the power law is, or sorry, the product law. Product law, if bases are the same, we multiply the arguments. So let's write number 1 for that first law. The second law is the quotient law. So the quotient law, and we'll highlight quotient law. Let's do this question over here. So for the quotient law, again, let's first evaluate each log individually. So log base 3 of 27, let's just do that in our heads. 3 to what power would give me 27? And Viola, what answer would that be? 3, yes. So this would be a 3 minus log base 3 of 3. So there's that one rule, same base, same argument. Marley, what would that be? 1. So this answer is going to be 2. The law, though, is if your bases are the same, then the logs are being subtracted, we could divide the arguments. So it's called the quotient law. So that would be log base 3 of, I'm going to put this argument in a bracket. That would be log base 3. 27 divided by 3 is 9. And then this you should be able to do in your head. 3 to what power gives you 9? The answer is 2. Okay. So those are the 2 laws of logs. There's going to be 3, but for this first half. Okay, we're going to do number 1 together, and then number B, I'm going to show you like a trick or a shortcut that I teach. So this one right here, log base 2 minus log base 2. As long as the bases are the same, we can do a law. If this is subtraction, the law is, it will be the quotient law, and you divide the argument. So that would be the log base 2 of 12 divided by 3. That would become the log base 2 of 4. And then the log base 2 of 4, 2 to what power gives you 4? The answer is 2. We're going to do this one in one step. So here's how we do it. I want you to write down equals. We have log base 6 plus log base 6 minus log base 6. So our log is going to be base 6. Let's write log base 6. Then what I want you to do is I want you to draw your division bar. If your log is positive, so this is a positive log, the argument goes on top in the numerator. So if your log is positive, the 9 is going to go on top. This log here is positive, right? The 8 goes on top. This log is negative, therefore the argument goes on the bottom. I'm going to put that in a bracket because that's going to be my new argument. 9 times 8 divided by 2. So this would be the log base 6 of 72 divided by 2. That is going to be equal to log base 6 of 36. And the log base 6 of 36, you should be able to do in your head. That answer is 2. So again, what I've done is I've done the laws in one step here. Because if I wouldn't have given you this, you would have said, oh, that's product law, 9 times 8, right? And then whatever that answer is, this would become quotient law. But we're going to do this step, like I'm going to give you several logs, and if you just remember that trick of if the log is positive, the argument goes on top. If the log is negative, the argument goes on the bottom. So let's see what it would look like. Okay. Class example 2. Use the laws of logarithms to write this as a single log. So let's first look. Log x, log base x, log base x, log base x. We got to get rid of this bracket. So this bracket's going to cause us an issue. So let's get rid of the bracket. There's a -1 there. So distribute that -1 in. So let's put that -1 and we're going to distribute this in. So what we have, write the entire thing. Log base x of 10 plus log base x of 75 minus log base x of 2 minus log base x of 3. Now I've got no brackets. We're going to write this as a single log in one step. This is equal to log base x of, draw your fraction bar, and you say to yourself, this log here is a positive log. The argument goes on top. So the 10 goes on top. It goes in the numerator. 75 also goes in the numerator because the log is positive. This log is a negative log. So that 2 goes in the denominator. This last log is a negative log. 3 goes in the denominator. I'm going to put this in a bracket, and I'm going to say that that is the log base x of, that would be 750 divided by 6, which is equal to the log base x of 125. Yeah. And you just went from 4 logs down to 1 log. Now what they say for B is they say evaluate if x is equal to 5. So let's take out this x and let's put in a 5. They want my base to be 5. So we'd say, okay, the log base 5 of 125. I'm just going to put an x here. A lot of you will be able to do this in your head. But for those that need to see this, 5 to the power of x is equal to 125. 5 to the power of x is equal to 5 to the power of 3 is equal to 125. Drop your bases and your answer is 3. So how I'm gonna write that, my conclusion statement would be the log base 5 of 125 is equal to 3. That's how I write that. Log base b, log base b, log base b, log base b. See if you can write this as a single logarithm. This one's even easier because we can have a bracket to get rid of. And just follow the rule. If the log is positive, put the argument in the numerator. If the log is negative, put the argument in the denominator. Okay, so you should be getting log base b of 6 over 48. You would reduce that. Log base b of 1 over 8. And that would be your answer, expressed as a single logarithm. Okay, now let's evaluate if b is equal to 2. So let's rewrite that, take out the b, and replace it with a 2. So log base 2 of 1/8. I'm going to let that equal to x. 2 to the power of x is equal to 1 over 8. 2 to the power of x is equal to 1 over 2 to the power of 3. Right now, this base is a half, so bring that 2 up to get into base 2, and that exponent becomes negative. So 2 to the power of x is equal to 2 to the power of negative 3. Drop your bases, x is equal to negative 3. So this answer, if I'm just going to erase it to write my conclusion statement, log base 2 of 1/8 is negative 3. That would be your answer. Okay. Log base 2, log base 2, log base 2, log base 2. So for all this crazy stuff, they're always going to have the same basis. We'll never trick you and give you different bases, right, to try to fool you. So what I want you to do the same thing. If the log is positive, please put the argument in the numerator. If the log is negative, put the argument in the denominator. And then we're going to see what happens with this one. So this log is a positive log, so the x goes in the numerator. This log is positive. The argument goes in the numerator. This log is a negative log, so that x squared goes down there in the denominator. And the last log, this guy is negative, so the y goes in the denominator. So you should have first that. Then let's clean up some stuff. So this would be equivalent to the log base 2 of, this is like 1x times 2x. So 1 times 2 is 2, x times x is x squared. So I would have 2x squared up here, all over x squared y. That's what I would have there. Then there's something else I can clean up. Cole, what do you want me to clean up from here? The x squareds can cancel. So those guys will cancel. And I would be left with log base 2 of 2 over y. So if you got to this step on a quiz, like if I gave you just this, and I said express as a single logarithm, you are done, right? That's the answer, log base 2 of 2 over y. But they made this a multiple choice question, and we look and we say, well, this answer is not anywhere. So what we have to be able to recognize, or what we have to sometimes be able to do, is we have to split this apart. So what law was it that had quotient law? Like, were the logs subtracted or were they added to get quotient law? They were subtracted. So if I say, can you please break this apart into 2 logs, what would it look like? This would be the log base 2 of 2 minus the log base 2 of y. right? Because think about it. If I gave you these two logs, right? So Kelly gets this. If I gave you these two logs, you'd be like, oh, I'm gonna use the quotient law, 2 over y, right? Divide the arguments. So now we have this. What is this guy?
1.
That is a 1. 1 minus log base 2 of y, and that answer should be there. Which one? D is the answer. I'm going to show you another example. Maybe just if you have room, jot this down, of this splitting apart business, okay? So let's say I gave you the log base 2 of 2x. So let's say you did all this stuff and you get to this answer here, and it doesn't match anything. This can be split apart. Do you guys know what, was this the product law or the quotient law? It was the product law, right? So if you had to split this apart, what this would be equal to is log base 2 of 2 plus log base 2 of x. Because if I gave you these two logs, you would say, oh, they're being added. That's the product law. You multiply the arguments to get 2x. So it would be log base 2 of 2x. So then we would, splitting it apart, we'd come to this. And then you'd say, okay, well, what is the log base 2 of 2? Well, that is 1 plus the log base 2 of x is how you do that. Last class example for this part, and then we're going to do, I'll do one homework question with you, and then I'll give you some time to do a couple other questions. This guy right here, 3 log base 2 of p minus 3 log base 2 of q. We only want to do the product law and the quotient law if your log has a coefficient of 1 in front of it. Then we're going to do the laws. So you say to yourself, well, if I got a 3 here and I got a 3 here, can I factor 3 out? Yes. So watch what happens. If I say, okay, I can factor out that 3. So the 3 goes in front of the bracket and the answer goes in the bracket. I would have the log base 2 of p minus the log base 2 of q. From here, take this and do the quotient law. So say to yourself, okay, this would become in one log, the log base 2 of p over q. This, whatever that answer is going to be, we're going to multiply by 3 at the end. Then the question says, oh, if you ever see a p over q, you could substitute that out for 8. So get rid of this guy and let's substitute it out for 8. So the log base 2, p over q, I'm taking that out and I'm putting in an 8. I'm going to multiply that by 3. This I could evaluate in my head because 2 to what power gives me 8. That answer is going to be 3 times the coefficient in front was a 3, and your final answer is 9. Okay. So those are the two laws. What I will do in the second half is going to be the power law. So there's one more law that we have to do, but I want you to practice first. So I want you to do questions 1 to 4, and we're going to do question 3 as a class. So I like this one because this one gets you to think. Okay, what this question is saying is it's saying use the laws of logs. There's only 2, product law and quotient law. And we're basically saying, is this statement going to be true or false? So what I want you to do is just ignore this. If I gave you this, log base b of 2 plus log base b of 3, what would the answer be? That's right. This would be the product law. Product law dictates that you multiply the arguments. So it would be 2 times 3, which would be the log base b of 6. That's the answer. So this is false. Right? That guy would be false. If a student did that work, what do you think they did? Like, what was the mistake that they made? They added the arguments. Yeah, they're like, oh, these 2 logs are being added. is what's the law? Do I add the arguments, right? So that's what this student did. Okay, let's do B. Log base B of 3 plus log base B of 4. Brian, what would this be?
The product law.
Yep, which would be what?
Log base B of 12.
Of what number?
12.
Yes. So is this true or false?
True.
This is true. Okay, again, I'm going to ignore this for now, and I'm going to do this. Marley, what answer would this be? Log base B of 8. So Marley, true or false? True. Okay, this one right here, log base B of 10 plus log base B of 10. Dane, what would that answer be?
Log base B of 100.
Log base B of 100, they did it correctly, right? This is the product law, 10 times 10 gives you an argument of 100. So this one's true. This one's a little bit tricky. So they did 2 times 3, which is 6. Okay, so that looks good. Does anybody know what the issue with this is? The answer is actually false. Why is this false? What would you say? That's right. The product law, you guys. So the only time we can apply the laws is if logs are being added or subtracted. That's it. You can only apply the product law if these 2 logs were being added, their answer is correct. Their answer is incorrect because they're being multiplied. So if I gave you this question, what you would need to do is you need to evaluate what this log is. You then need to evaluate what this log is, and you need to multiply those 2 numbers together. That's going to give you your answer. Okay? So you cannot apply a law for multiplication. There's no law here. Same with this guy, right? This technically, if I rewrote this, let's rewrite this guy. This is the log base B of 8 divided by the log base B of 2, right? So they said, oh, this is the quotient law, and they divided these arguments? No. In order to apply the quotient law, what operation do I need here? A subtraction. So this is going to be false. You cannot do that. If I gave you this question on a test, I'd have to give you what the base is. You figure out what this log is, you figure out what this log is, and you divide those 2 numbers, right? We can't do a law for here, we can't do a law for here. I actually really like this question. Let's try G together. So, Sydney, what law would this be? It would be the product law. So that would be log base B of, we've got to multiply the arguments. So 3 to the power of 2 times 3 to the power of negative 2. So let's figure out what this would be. That would be log base B of, now we're going to exponent laws from grade 10. Bases are the same. So I'm going to write my base of 3. What do I do to these 2 numbers? You add them. So if bases are the same, and they're being multiplied, we add the exponents. 2 plus negative 2 is 0. Okay, what is any number to the power of 0? It is 1. The log base B of 1, what is the answer whenever our argument is 1? The answer is 0. Is it true or false? This guy's true. Oops, true. Okay. This one here, and this one, I actually thought these were a little bit tricky, these guys. Can you just look at this and pull it apart? So take this and pull it apart. So say, what law did they use to get 5 over 3, and then pull that guy apart? Read it to me what the answer would be.
Log base B on 5 minus log base B.
That's right. Yeah. So this pulled apart would be this. Therefore, is this true or false? It is false. Okay. How was it I did this one? I remember this one. we were looking at it. Log base b of 1/8. Oh, we're gonna do the same thing that we did here. Can you take this and pull it apart for me? So take this left side and pull it apart. Viola, read me what you would get.
Log base b of 1 minus log base b of 8.
Perfect, minus log base b of 8, okay? From here, what is the log base b of 1? Any argument of 1, what does that give us? 0 minus log base b of 8. 0 minus log base b of 8, I can simply do this, but I don't need that 0 there. And my answer is negative log base b of 8. True or false? True. Yeah. So these ones, again, if you see this, you can pull it apart using the quotient law. So this one's true. So you try 1, 2, and 4.